Similar triangles. It's pretty easy to prove two triangles similar. What you first need to know is that similar triangles we can say fit inside each other. It means they have three pairs of equal angles, which we call equiangular, and their corresponding sides are in proportion. Let's look at this example over here. In the diagram, all the angles are equal. So they're equiangular, so those triangles are equal. But their sides are in proportion. If I look at this side, 8 over 4. If I write it as a proportion problem, 8 over 4, that can be simplified to 2 over 1, and I can do it to all the sides. Take 6 over 3, and I can simplify that to 2 over 1. If I take 4 over 2, that simplifies to 2 over 1. So all these sides are in proportion, and the angles are equal. If I use sides in proportion as my reason, all I need to do is take corresponding sides, write them as proportion problems, and see, do they all simplify to the same proportion? If so, then these triangles are similar, and we say sides in proportion would be our reason. But what I want to work on is proving two triangles similar. When we prove them, we can prove that all the angles are equal by proving two of the angles are equal, and we can state the third angle is equal because some angles of a triangle. Or the second proof is sides in proportion, which I'm not really going to focus on. We looked at it over here. Prove all the corresponding sides are in proportion, and those triangles will be similar. But let's look at an example where I've got some sides. I've got the lengths of those sides. But I don't have all the sides, so I can't prove sides in proportion. What I'm going to do is try and prove all the angles are equal. Step 1 is we state the triangles we're working with. So in triangle ABC, remember the word and, triangle AED, I need to prove 3 angles are equal. Well, easy here. We know those are equal. A1 is equal to A2 because they have vertically opposite angles. I also have parallel lines shown here. We know with parallel lines corresponding angles are equal, but also alternate angles are equal. And I can see if I draw it in here that angle B is going to be equal to angle E. Angle B is equal to angle E because they are alternate angles. Alternate angles are equal. Put in your parallel lines. CB parallel to ED. Last one is also going to be equal. C will be equal to angle D. They are also corresponding angles. But in similarity, it's also easy to just go C is equal to D because some angles of a triangle. The last angle will always be equal because some angles of a triangle. Obviously, if that's equal to that and that's equal to that, and they add up to 180 degrees, then that must be equal to that. And we'll finish off. Therefore, triangle ABC is similar to triangle AED. My reason is angle, angle, angle. And the order these triangles are named in is very important. This shows me angle A is equal to angle E. Angle B is equal to angle A is equal to angle A. Angle B is equal to angle E. And angle C is equal to angle D, which is what we've proven over here. But it's going to be important when we work on the next question, because in the same diagram, I want to calculate the length of AB and EB. So knowing that these triangles are similar, we've just proven it over here. We've proven the triangles are similar. I can go and find the lengths by writing the sides that are in proportion. And so the naming was also important because it shows me AB is in proportion to AE. So we write it as a proportion problem, AE. And BC is in proportion to ED. BC in proportion to ED. Remember to put your equal signs. And lastly, AC. Sorry, just froze there. AC over AD. AC over AD. Remember, I'm looking for the length here of this one there. So I go and I fill in what I have. I don't have AB, that's what we're looking for. I do have AE. And I've got BC, that they tell me is 12, and I've got ED, tell me is 9. And I've got AC is 14, and AD I still don't have. And I could go and find that. Because I'm working with sides in proportion, look what we have here. We've got one completed side that is in proportion, and I've got one missing proportion. So we just write that down. We're going to work with this one here. You must always have one complete and one missing side. So let's write it down. AB over 6 is equal to 12 over 9. And using what we know about proportion, direct proportion, we can cross multiply. It's going to give me 9AB is equal to 72. And I divide both sides by 9. I'm going to get AB is equal to, divide 72 by 9, you're going to get 13,3 recurring. And there we go, we found AB using sides in proportion. And easy to find EB. EB is this long one there. You're just going to say 6 plus this 13,3 and get your answer. Again, now I'm asked to find the length of x. To do that, I need to prove similarity first. So let's quickly go and prove similarity. Work with this little triangle here, and then go and work with the big triangle. Those are going to be my two triangles. Start with in triangle ABC and triangle ADE. Three things I want to prove. Look here. A is in both triangles. So we can say A is equal to A, angle A is equal to angle A. There's a common angle. I've got these parallel lines here, and I can see there we can draw an F shape. So angle B is going to be equal to angle D, corresponding angles. And I'm going to take a shortcut here if you don't mind and just say put in your parallel lines. And always in similarity, the last angle is going to be equal. C is equal to angle E, again corresponding angles, or you can just say sum angles of a triangle. Now you've got your three angles, so there we go. Therefore, triangle ABC is similar to triangle. Again, be careful here. You've got to match up your triangles. So we said angle A was equal to angle A, angle B was equal to angle D, and angle C was equal to angle E. So it must go in the correct order. Put down your reason. All three angles are equal. From that, I can go and find x. I'm going to be looking for that x, writing my sides in proportion. I'm going to just come up here quickly. AB over AD is equal to BC over DE is equal to AC over AE. Remember, I read it off my triangles there. AB over AD, AC over AE, etc., etc. Fill in what we know. We don't have AB, we don't have AD. BC is 3,5, and DE is what we're looking for, is x, and AC is 7, and AE is 8. Remember, we've got a complete proportion here, and we've got our missing proportion. We're going to cross multiply and get 7x over 8 multiplied by 3,5 gives me 28. Not over, sorry. 7x is equal to 28. We divide both sides by 7, and we're going to get x is equal to 4. So using sides written as proportions, we're able to find it. So two important things about similar triangles. All their angles are equal, and their sides have to be in proportion. Either prove the sides are in proportion, or do what we've done here, prove their angles are equal, and you can find missing sides. Pretty straightforward.